everyone. Today we're going to continue to learn about physical sciences. Before we do, I have another fun toy. I have this toy with 1, 2, 3, 4, 5, 6, 7, 8 discs that I'm going to try to balance into one straight line. You can see that it is not easy. It is all wobbly all over the place. Let's see if I can do it. And again, I'm going to do it without touching any of the other discs. I'm just going to hold it straight. I have 2 on top and 2 on bottom. Oh, I got 3, 4, 5, 6. Almost there. The last 2. Oh, I did it. Look at that. And now they're not coming apart. I can move it around. Am I great or what? Do you think that I'm just great at balancing, or do you think that I have a little bit of help? Well, I can make it fall apart again. They're not stuck together whatsoever. They're not glued together at the center. But let's take a closer look and see what is helping me. Oh, and look, they're balancing once again. Taking a closer look, you'll see that there are these tiny metal circles inside of each of these discs. Now, do you think those metal discs have any power? What do you think they are? Take a minute and think about if this has any purpose. And if it does, then what is it? Any idea what these are? That's right. They are magnets, tiny, tiny little magnets with just enough power to help me to be able to balance these. Now we want to see how these magnets are formed and how they're shaped and how they've created such a toy. For this part of the lab, you will need your 2 donut magnets from your enrichment bag. Now you'll see the 2 donut magnets are stuck to one another. You'll need to apply a little bit of pressure and break them apart. Now, these magnets look like they are identical on both sides. But are they identical? Let's see. If I bring one magnet close, picks the other one right up, and they get stuck to one another. What about if I flip it around to the other side and bring it close? It's not doing the same thing. In fact, it's pushing the other magnet away. Now, magnets, similar to static electricity, also have charges. They have a positive and a negative, or a north and south as we call it on magnets. Now, the same concept applies to magnets. Similar charges repel, opposite charges attract. Can you guess what charges are on these magnets? There's a magnet here, and there's another one there. These 2 magnets are attracting one another. Are they similar charges or opposite charges? Before you answer that question, let's look at our magnets up close. Here I have my two magnets. What I'm going to do first is take one side and bring it close, and quickly the magnet on the bottom flew to the top, and they are now stuck to one another. Looking at our two magnets, this side and this side, this side must be opposite from this side. Now let's see what happens when we bring similar charges next to one another. As I bring it close, the other one is being pushed away. For this next part of the lab, you're going to need a pencil and your two donut magnets. What I want to see is, can you have your magnets stack onto this pencil without touching one another? Take a minute, draw what you think it's going to look like. Make sure to label the charges as you draw your magnets onto the pencil. Did you figure it out? Let's try it. If I'm going to add one of my donut magnets onto my pencil, and I want the other one to float right on top. Is that floating? No. What do I have to do to get one to float onto the other? That's right. I have to flip it around. So I'm going to take my magnet off and flip it. And whoa, look at that. I'm actually able to move this magnet without even touching it. The similar charges are repelling one another, causing them to move. So if this side is positive, that side must be positive. Well, let's try what if we flip it around the other way. I'm going to hold my pencil up top, take one magnet out and flip it, and then take the other one and flip it as well, and we should see the same thing happen. Well, it does. Opposite charges repel. Similar charges attract. And I'm able to move one magnet by touching the other one. Magnets do not need to be in contact with one another to be able to move them. Magnets don't have to be in direct contact to have power. Now, I was at a store the other day and I saw the salesman selling something that says, this can actually answer all of your questions. Well, sometimes I wonder, what's gonna happen later on today? What's for dinner? I'm gonna ask a question. Am I going to have pasta for dinner? Well, some of the answers are definitely, no way, try again, ask a friend, yes, and maybe. Let's try it out and see what the outcome is. Let's try it again. Oh, wow. This says I am definitely having pasta for dinner tonight. I spun this a few different times and it landed on two different options. Now let's see, it could land on maybe, It could land on yes, ask a friend, try again, no way, and definitely. How does this work? Well, I think we know the answer. There must be a magnet here. And this is not a magnet I can feel, but this is magnetic. And so it will land on wherever it's feeling the most attraction to. Again, you'll see that magnets don't have to be in direct contact to exert power. Another really, really great toy. Fun, but you know what I'm going to ask next? Let's make our own version. From your enrichment bag, you're going to need your 2 pieces of string, your 2 paper clips, and your 2 magnets. You will also need to provide a few pieces of tape. The first thing you want to do is pull your string through your paper clip and tie a knot. You may already have it ready from the Pendulum Lab. And I'm going to do that with a second one as well. Now you want to make sure that these 2 are similar lengths, and mine are. Next, I'm going to lay the 2 pieces of string next to one another, and using my tape, tape it onto tape it onto the table. And now I'm going to see if I can move my paper clip and have it float in the air without touching. Look at that. If I get too far, the magnet no longer has power on the paper clip. But if I am just at the right distance, then the paper clip floats in the air. Now we can try this with 2 magnets. And see if you can get both to float. Oh, look at that. I got it. Well, how fun, right? I was able to recreate a version of this toy, right? This is a little bit different. This has many, many different magnets all around with one piece that's able to go in many different directions. And what you can see is the distance is the same all around. There's no magnet in the middle. That's why it will not stay in the middle. But since it is a circle, any point in the circle, it's exactly the same distance that it has from the magnet. So to really recreate this, I would need 1, 2, 3, 4, 5, 6 magnets. And this would be my paperclip on a string. But what this demonstrates is the power of magnets and how they have the power to exert a force even when they are not touching. Go ahead, try these experiments to fill out your sheets. Good luck.